Assalamualaikum and hi, my name is Abdul Yafiq Hazwan bin Abdul Rahman from Section 1, Group 1. Today, we will be presenting about equilibrium of forces. Equilibrium of forces, a very basic concept when dealing with forces, is the idea of equilibrium or balance. If the size and direction of the forces acting on an object are exactly balanced, then there are no net force acting on the object, and the object is said to be in equilibrium. A force is a vector quantity, which means that it has both a magnitude and a direction associated with it. Because there are no net force acting on an object, then from Newton's first law of motion, an object at rest will stay at rest, and an object in motion will stay in motion. This concept is called inertia. The objective of this project is to investigate the relationship between the total weight and the angle obtained and relate them to the concept of parallelogram of forces. This project also informs us that the ratio of the specific angle obtained from this experiment between angle 1 and angle 2.
Thank you to Yafiq for the presentation. Now I will continue this presentation about the additional theory of this topic. The theory of parallelogram of forces states that the resultant force of several forces equals to the total sum of the forces. When this incident happens, the forces achieve total equilibrium state. However, the angle of the respective forces varies depends on the weight given. If one force holds a larger weight, the angle of the force with the resultant force is larger. On the other hand, if the force holds a smaller weight, the angle of the force with the resultant force is smaller. But in the end, the experiment will always be in an equilibrium state.
Based on this equilibrium of forces experiment, the example that we chose to be the application in our daily life is hanging sign on the wall. This picture represents the example of equilibrium of forces. For example, consider the picture at the right that hangs on the wall. The picture is in a state of equilibrium, and thus all the forces acting upon the picture must be balanced. That is, all horizontal components must equal to 0 Newton and all vertical components must equal to 0 Newton. The leftward pull of cable A must balance the rightward pull of cable B, and the sum of upward pull of cable A and cable B must balance the weight of the sign. That's all from me, and we will proceed to the next presenter. Thank you.
One of the example of the application of the equilibrium of forces is when we are pushing a heavy block. While pushing a heavy block, the block does not even move although we applied a significant amount of force. But we can feel the presence of a force of friction. The force of friction has a greater magnitude than the force that we apply to it, and it acts at the opposite direction from the force that we apply to it, and does not change the position of the block.
Assalamualaikum. So today I want to present about the conclusion and recommendations for this topic for our presentation. In closing, a parallelogram is a two-dimensional geometrical shape with each side parallel with the other. There are two methods for calculating the resultant force in parallelogram. The first method is to go from head to tail using a scale diagram. And the second method is to use the Pythagorean theorem. As a result, both graph clearly shows that W1 divided by W2 equal to F1 divided by F2 is directly proportional with sin theta 2 divided by sin theta 1. We encountered difficulties while completing angle reading tasks. We overcome it by ensuring that the position of the reader's eye is proportional to the thread before reading the angles. That's all from me.